Today we're going to be talking about graphing linear and absolute value inequalities. So graphing a linear inequality is just like graphing any old line, just you have to remember to shade because the shading gives you all of your possible answers. So graphing this line, we need to solve for y. So I'm going to subtract the x over, and then I'm going to divide by -2. Remember, anytime you divide by a negative, you have to switch the sign. So that's the equation of the line we get. Now what you're going to do is -2. You're going to graph your line. Now this is the part that not only I forget to do, but a lot of students forget to do. I'm just putting a lot of points on there. Is they need to remember dashed line. So it's a dashed line. So now that I have this dashed line, I need to figure out where I'm going to shade. This symbol, as long as the y is on the left, this symbol right here is greater than. So that means I'm going to be shading above the line. Now what you can do is you can test a point. And if that point makes a true inequality statement, you've shaded the correct region. So I've tested 0, 0. So I plug in 0 for y, 0 for x, and 0 is greater than -2. That is a true statement, so I've shaded the correct region. Remember that if you test a point that's outside the region, like say, what is this, 1, 2, 3, 4, 5, if we test 0, -5, -5 greater than 2 times 0, which is 0 minus 2, -5 is definitely not greater than -2, so that point isn't a solution to our linear inequality. Our next example. A tutoring company, and yes, I want you to write all this down, advertises that it specializes in helping students who have a combined score in the SAT is 900 or less. So write an inequality to describe the combined scores of students who are prospective tutoring clients. X is going to represent our verbal and Y is the math. So our X score plus our Y score is, so I need my equal to sign, these scores have to be less than 900. So solving that for Y, and if you wanted you could do intercepts, we get that equation. On the bottom we had verbal. Over here we have math. So now I'm up. I'm going to go by 100s. So if I count out my slope is a -1. So I keep going down. It's kind of nice because it goes right through the corners. We have that right there. And since it's less than, it's technically everything below. So now, does a student with a verbal score of 480 and a math score, which is Y, of 410 fit the guidelines? So basically, does this point of 480, 410, is that make this inequality true. So I'm actually going to plug it into this top one. So plugging it into the top one, x is 480 plus 410 less than or equal to 900. Well, that ends up being 890 less than or equal to 900. So yes, it does. And if you think about it, 480 for x would be all the way over somewhere here, and 410, that would be approximately right there. So that point is in our shaded region, so that makes sense. Our next example, now we're graphing an absolute value, but put this into our standard form. Remember, our standard form is this. So we want to add the 4 over to the other side. And I'm just going to re-highlight that's minus a negative 5 plus 4. So now what we're going to do is x minus a negative 5. So I go over 5 and I go up 4. That's my vertex. My slope is 2/3, so I go up 2, over 3, up 2, left 3, left and right 3. Now be careful, dashed. It's a dashed line. So now that we know and realize that we're dashed, I now need to figure out how I'm going to shade. It says y is greater than. If I were to plug in 0, 0, 0, which would hopefully not make this inequality true. Plugging in 0, 0, 0, 2/3, x minus 0, 0 plus 5 plus 4. Is 0 greater than? Doesn't even really matter what this number is going to be. 0 is definitely not greater than a positive number, so this is not true. Or you can remember, I'm greater than, I'm shading above. So 0, 0 wasn't a solution, but everything that is in our shaded area is a possible solution. Okay, our next example. And this one's a little bit different, but if you remember the idea of absolute values, you should be fine. So, graphing that inequality. Remember that x minus 3y, absolute values can be positive, or x minus 3y can be negative, but you have to switch the sign when you incorporate that negative. So now solve each one of those equations for y. I have negative 3y less than negative x plus 6. I divide by my negative, so I switch my sign. So now I graph this equation. It's a dashed line. So for this one, we're going to be shading above. So let's deal with that in a minute. Now, our second one, I'm going to solve for y. So I'm going to subtract the x over. I'm going to divide by a negative and switch my sign. It's going to be a positive 1/3 x plus a 2. So it looks like our lines are parallel. And you guys can hear the bulldozers in the background. Fabulous, fun part of our new building being built. For those of you guys that are maybe listening to this in future years, that's why we get to sit in a brand new fun building. Okay, so now let's talk about our shading. When you have our first equation, y is greater than, we shaded above. We were shading above. When we had the other equation, we were shading below. So it turns out that when we were shading here, we're shading everything in between. As usual, let's test a point. If we test 0, 0, in our original inequality, does that become true? So I have 0 minus 0 less than 6, so is 0 less than 6? Yes, that works. I did just one test point, which tells me that I graphed it right and shaded correctly. Okay, you have 2 lesson questions. You need to figure out for part A, which one is our graph, so a multiple choice. And for number 2, again, we have another multiple choice. And please make sure that is submitted on time.